Hey everyone, sorry for the delay in getting started here. My name is Carl Mall, and I am the technical project advocate here at FINOS. Started in December. A little bit of a background for me is, so I worked at Symphony Communications from 2017 to 2021, so that's where my introduction to working in cross financial services workflows, particularly in deploying chatbots cross-firm, which has a lot of applicability to standards and working groups in being able to figure out what are standards of workflows between firms for use cases like post-trade reconciliation. The last several years, I've been working heavily in the open source space before coming to FINOS. I'm sure most people here are familiar with FINOS, the FinTech Open Source Foundation. We're independent, nonprofit, and fully supported by membership, and we are under the Linux Foundation. We are particularly focused on being independent, neutral, and compliant steward for open source collaboration between financial services and fintech. We have 75 member organizations, 50 open projects, and one of our big initiatives is the Open Source Readiness Initiative and the Open Source in Finance Forum, which will be happening in London this summer and New York in the fall. So before we fully get started here, just want to go through the meeting notice, which is part of our compliance in terms of being an independent, neutral, and compliant steward. So FINOS project leads are responsible for observing the FINOS guidelines for running project meetings. Project maintainers can find additional resources in the FINOS maintainers cheat sheet. All participants in FINOS project meetings are subject to the LF Antitrust Policy, the FINOS Community Code of Conduct, and all other FINOS policies. FINOS meetings involve participation by industry competitors, and it is the intention of FINOS and the Linux Foundation to conduct all of its activities in accordance with applicable antitrust and competition laws. It is therefore extremely important that attendees adhere to meeting agendas and be aware of and not participate in any activities that are prohibited under applicable U.S. state, federal, and foreign antitrust or competition laws. Please contact legal@finos.org with any questions. FINOS project meetings may be recorded for the use solely by the FINOS team for administration purposes. In very limited instances and with explicit approval, recordings may be made more widely available. And on that note, we are going to be recording the presenters for this call. The video stops at the front of the stage, so attendees are not going to be on screen, but please note that if you do want to ask questions on the mic during the call, that those questions will be recorded. At the end of the day today, we'll be moving to a more unofficial whiteboarded session, which will allow for conversations that will not be on the recording. And then finally, I just want to put up on the board our community code of conduct. This is findable on the FINOS website, but all events hosted by FINOS are hosted under the FINOS code of conduct. And with that, I'm going to hand things over to Lita. You got to start. Yep. And now introducing Dan, Litek, and Tom as part of our intros to get things kicked off.
We said we'd do introductions. So the other presenters today are Litek from ISDA, the International Swap Derivatives Association, and Dan Schwartz, independent consultant, FT Advisory, right? Do you guys want to do a quick intro? Yeah.
Yes, Litek from ISDA. I've been working at ISDA for the past 16 plus years on FPML, financial products markup language, as well as on CDM and digital regulatory reporting. I've also been looking at regulatory reporting since the financial crisis. So essentially developing the regulatory framework in FPML.
So I'm Dan Schwartz. I'm the managing partner at FT Advisory, which is a capital markets technology products consulting firm, strategy, architecture, and implementation. I'm ex-managing director at NatWest Markets and have ex-colleagues in the room, and was CIO at Cloud Margin thereafter, and also CTO for fixed income at Citi. I know that the theme today is getting started with CDM. I'm a working example of getting started with CDM with a group of two other independent firms. We wrote the generator that converts Rosetta and therefore CDM into Python. I'm a member, that led to a technical engagement. I've been a member of the Technical Architecture Working Group since its founding, and we'll talk more about the goals for that group, but essentially we're looking to, that remit is to help define the CDM's technology roadmap and facilitate its implementation. And I guess the last point is, why did I get started in CDM? I have a long background in OTC derivatives, and CDM is my penance for all the horrible things I've done. There we go.
Great. We're going to cover quite a bit of material today. We're starting at the high level. If you didn't have any background or understanding of CDM, where it came from, who are the organizations involved, you'll get an understanding of that. But we're going to then go, because the survey that was sent out to get feedback on what this session actually should be, we got feedback. This is an intro getting started session. And so we are going to dig right into the model itself, how the model is designed for financial products, and actually building a small application. I have a small application that's built using the CDM. I see you guys brought your laptops. If you actually want to get down into actually building something, it's actually pretty quickly to get started. You're going to see the model itself, you're going to think like it's very complicated, but then when you see it actually in use, I think you're going to see that it's actually very easy to get started with it. And we can go in two directions depending on kind of what you hope to get out of it and understand. One is the building of the applications direction, and the other is model changes. So if you're interested in how to work with the model, rebuild the model, we can do that as well. So I'm not specifically reading down this list here. You can see how things are going to progress. This is really the first time we've run anything like this in New York, or actually in the United States. Most of the work on the CDM has been done out of the United Kingdom, where the three organizations are located, except for ISDA is covered in both locations. But most of the sessions that we've run, most of the in-person sessions, we had a CDM showcase event in February with close to 150 people or so that attended. We've been doing this every year. So this is the first time that now working with FINOS that we're able to actually do something like this here in New York. It's a really great way to get started. I would also say that I've been working with the CDM for quite a while, building applications. My background is primarily derivatives, foreign exchange, and repo, and that's really through the repo work that I've been working with the ICMA. That's their primary focus. I'd say probably among all the groups that have been working with it, maybe there are a dozen or so experts out there that have really fully understood the whole model and how to work with it and everything. So most of them are at Regnosis, the firm that started it. And so I'm really hopeful today that you guys really learn and get engaged with it and become experts as well here in New York. You'll be probably the first experts in the United States. With that.
And just before we get started, a couple housekeeping notes. If you need coffee or snacks or water during the event, all the coffee and snacks and water out here are for us. So at some point, if we will also want to maybe take a 5-minute break between two steps, if there's a natural break point, we've got the coffee and water there. If you have any more advanced questions throughout the session, we will be having an open whiteboard Q&A integration time. We have plenty of time scheduled for that at the end, and we'll be hopefully diving into advanced questions and advanced use cases. So if we're not able to cover anything during the session, we've got plenty of time afterwards.
And just to get us started through the background and the history, I'm back. First time we're running this. So let me give you a little background on the history of the CDM and what is the genesis of it. And all of you are from the financial services space, so you know all about the complications and difficulties that many of the different entities in the industry, the banks, the dealers, the clearing agents, the settlement agents, the service providers, everyone has externally problems in terms of sharing data and the format and structure of that data. I've been at many banks, been at financial services firms. I know internally the application models, because of the many years that they've been built, that there are many different models of those financial products, right? Some of them may be structured, some of them are very flat structures, but they're very difficult, sometimes just getting one application to work with another application. So the genesis of this was to establish a common representation of financial products and be able to share that model so that the representation of that could be shared among many different applications. That in itself, I'm sure, doesn't necessarily sound particularly new. You probably heard it and you work with data models yourself. The difference in this case is that the model is extended to do two different things. One is it has an event model built into it. So the services that are needed through, let's say, the life cycle of a transaction, they are all built into the model itself. So it was really targeted for addressing all the issues that are in the industry that you have around when data is inconsistent and representations are inconsistent, where you have reconciliation problems, valuation problems, collateral disputes is a very common issue across derivatives and repo. There's operational problems on failures and so on. So all of what was intended to be, that occurs related to these issues was intended to be addressed by the CDM. So the CDM, as I mentioned, first started with the representation of financial products. It has an event model built into it. To fully represent the engagement of counterparties, you need a legal agreement model, so that's included. There is process definition within the CDM in terms of actually how events are processed. Reference data components, there's reference data models built into the CDM as well as extensions to go externally. And then there is a mapping process. So we recognize the CDM, really want the CDM to be at its core, have a pure, clean model. So other models really aren't coming in to dilute the structure of the model. So we work through mapping structures in order to interface with other products. So the benefits really are that you can get significant efficiency out of sharing the same model. It's completely transparent, so you'll see how the model actually represents products and actually represents them you'll see these JSON structures that we use. They're shareable, so it's very transparent to see exactly what it is. The model itself, we said another parent of transparency, the model itself is completely open. We're on FINOS. Other parts of building the model have become open as well. The code generators that generate the code for the model and the actual building components, you'll see, are also coming open. And regulation is a very big part of this whole process. And there's in production already applications, one called the Digital Regulatory Reporting Module, which is actually used for reporting when in live with the reporting for CFTC. You can see that what was accomplished here was to fully make this model something that is very extensible, something that is very scalable and technology agnostic, and it accomplishes many of these goals once you start to see how the model actually gets implemented. And
CDM is sponsored by 3 trade associations under FINOS. So the International Swaps and Derivatives Association, ISDA, the International Securities Lending Association, ISLA, and the International Capital Market Association, ICMA. So the 3 associations have signed a memorandum of understanding back in 2021 to strengthen collaboration on the future development of the common domain model. And this memorandum, this agreement, essentially establishes a framework for closer collaboration between the 3 associations. And it provides a path for joint governance and setting out arrangements in relation to the open source components of the CDM. And the collaboration is essentially intended to unlock further synergies in the development of the CDM across financial markets, creating efficiencies for market participants, and setting digital standards that will enable the use of innovative technologies in the future, now and in the future. So essentially, this slide aims to represent the work from the 3, sponsored by the 3 associations under the aegis of FINOS. And what that means is that with that collaboration, we can align our roadmaps. We were able to align the different working groups that are held, as well as have an open source repository provided by under FINOS. And essentially the goal is that this association benefits the entire industry. So the trade associations appointed to provide the repository for CDM and essentially take advantage of the open source community and the expertise that FINOS is providing. In this slide, I'll be talking just a couple of minutes about the history of CDM. So CDM is about 6 or 7 years in the making. It started under ISDA as a project so back in 2016, ISDA published a white paper on how we could improve the derivatives market in terms of processing. And subsequent to that white paper, there was a design paper that was published, an RFQ to select a vendor that would build the solution. That vendor is Regnosis. And in 2018, the first version of CDM was created as a conceptual pilot. CDM 2.0 in 2019. So it included some derivatives product in rates and credit, as well as credit support annex legal documentation, and it was made available to the market. Additional CSAs were added in 2020 for initial margin and variation margin, and additional products were added in FX and equities. In 2021, the first non-derivatives products were contributed by ISLA for securities lending. And in 2022, there was an iteration of the digital regulatory reporting, so DR. So essentially, CDM can be used to report trades to regulators and trade repositories. IGMA also contributed in 2022 to the repos model. In early February 2023, CDM migrated to FINOS, the open source community, version 4.0 published last July. And since then, we've added more products, ETDs, commodity derivatives, and the ISLA master agreement. The Global Master Securities Lending Agreement was added in version 5, and additional repo and bond. Tom discussed about products in CDM. So this slide provides an overview, a partial list of all the products that are covered in CDM. So it started with derivatives. So we have different products in rates, credit, equity, FX, and commodity derivatives. For rates, we have swaps, different flavors of swaps that are covered, cross-currency swap, non-deliverable swaps, basis swaps. For credit, we have credit default swaps, including variations related to basket, tranche, and we also have options that are covered. For equity derivatives, we have TRS, single name index basket, dividend correlation swap, and we also have options and forwards. For FX, CDM allows to represent FX swap, forward, non-deliverable forwards, options, and similarly, we have their support for commodity derivatives more recently with commodity swaps, options, and swaptions. And the ETDs are now also supported. There's additional products in other areas. So we have vanilla products for bonds, equities, FX, commodities, and funds. And in the financing area, we have repurchase agreements, so repo. So we have different types that are supported, as well as securities lending. So single underlier, cash, open term, security loan. And what's important to note is that the way CDM works is that it uses common elements at the basis, and which are used to compose additional products. So the list that is specified here isn't an exhaustive list of all the possible combinations that can be represented in CDM. So this slide is just to give you an overview of what's available. The next slide is about event coverage. CDM includes data structures to represent the lifecycle events of financial transactions. And so there are, on the left side, there are some primitive events that you can use, which are generic and broadly applied to most financial transactions. So examples of such primitive events would be like execution, confirmation, termination, transfer, change in terms, change in quantities. So these are all primitive events in CDM that can be leveraged. And then there are events that are more specific to different domains, like security and derivatives events. In those domains, we can have innovations, terminations, compression. So this is a list of what's available, allocation. And then for the repo, CDM also covers repo lifecycle events, and they are listed on the right side. For example, we can specify reprice, re-rate, adjustment, substitution, interest payment, and whatnot. And again, this is not an exhaustive list because since we have primitive events, more complex events can be created of the primitive events. And with that, let me turn it over to Dan.
Thank you, Litek. So we're going to talk a little bit about the governance just to give you an orientation. Of course, as you saw earlier, CDM comes together under FINOS, but with 3 trade associations who are helping set the sponsorship and drive the roadmap. It's an open source project under FINOS, and so what's important about that is that fundamentally the governance works by consensus. So as you see each of these boxes, and we'll go into detail on some others, the aim is for there not to be a top-down, this you shall do, but more that the group comes together and what the right thing is to move forward. Sometimes it's a heated conversation, but we do our best to come together with common purpose. At the core of the governance is the steering working group, and it's very similar to those who've worked with or larger organizations for a steering committee. And it essentially it's there to set the roadmap and facilitate its execution. And what that can mean is allocation of resources or helping resolve complex issues that can't be resolved in the working groups themselves. Ideally, it's to put forward resourcing and allocate resourcing towards the higher priorities. I don't think we're going to talk about the release process itself, but there's a concept of major releases and minor releases and bug fixes. And so it's a similar thing to semantic versioning, right? The major releases, which are defined as major because they have such big change that it may be breaking from a prior release. The SWG is the point of providing approval and governance over major releases. Minor releases, smaller changes, bug fixes, etc., are, of course, under the SWG's purview, but it's delegated down primarily into the contribution working group. I think that's a good way to think about how the steering working group works. And then, like in any other program, you have other working groups that are contributing, right? I'm not going to cover in any detail the contribution working group and the technology architecture working group because those are covered in the next slide. But what you should know is that those two are horizontal in that the contribution working group is deciding what gets into the next release or proposing what goes into a major release. And the technology architecture working group dealing with technology issues across the platform. The modeling working groups, that is the business functionality, that's happening in domain working groups. And you'll see a list at the bottom here of some of the working groups that existed as of the 24th. Dynamic environment, there can be new working groups formed. In fact, I think today or yesterday there was new task force formed. They're domain specific: collateral, repos and bonds, securities lending, derivative products and business events, structured products, DR peer review, and ISDA legal agreements. Some of these are directly under FINOS. Like, for example, the derivatives products working group is directly under FINOS. Others are hybrid groups where they may be trade association sponsored. Modeling changes come from that, but will come back into the CDM. So it's a pretty dynamic and fluid organizational process. Then there are some very specific working groups that are actively FINOS under the CDM under FINOS, or under FINOS under the CDM. The contribution working group meets every other week. The next meeting is on the 16th. Yeah, April 16th. It was a setup slide. See if you guys are paying, if you folks are paying attention. Clearly you were. Anyway, and I think the reason to highlight the date is these are all open working groups. You can go to the community calendar, find out the schedule, and join the working groups that you have interest in. And the thing, I think that if you want to contribute, there's some other things that need to happen. But anybody's welcome to participate under FINOS guidelines, so constructively. Carl has a comment.
And just as a quick note, we'll show up a QR code to the FINOS Getting Started page, which has links to the contributor license agreement, that has links to the good first issues in the repos and has best practices. And we'll also have a QR code showing the link to the common domain model repo and under FINOS. So if you would like those without having to memorize these, we'll have those available at the end of the presentation.
And point of fact is, almost all the material that you've seen today, you'll be able to see in some form or another under the CDM, the GitHub repo. So if you're trying to, like, we're going too fast, or a slide, a picture, or something that you want to hold on to, you'll probably be able to find it just by going to the repo itself. So contribution working group, its goal is to gate contributions. People raise PRs, they've been approved, how do they get into a release? Anything else to resolve issues that may come up along the way. There may be modeling conflicts, there may be other aspects, there may be timing concerns. That would be a contribution working group. And the technology architecture working group, which is, again, where I find myself spending most of my time with respect to CDM, its objective is to try to deal with non-functional challenges that the platform has and set the roadmap for how we'll resolve them. For example, the way that, so we haven't talked in a lot of detail, but basically there's a model, and there's code libraries that are produced from the model using a generator. The way that machinery works today is in using a proprietary technology. We want to move it to GitHub Actions. That's the kind of thing that the technology architecture working group gets involved in. So if you're angling for interesting technical challenges that can really change the industry, that might be a place to join. We meet the second Thursday of every month, and the next meeting is, I think, before June 8th. But this one I caught. Anyway, I think the next meeting is in April. And the schedule is there. And similar thing to establish the technical roadmap, facilitates execution. The technology architecture working group, because some of these issues are pretty complicated, we spin up any number of task forces, either to your delight or your pain, depending. Because it's the only way to really work through some of the issues that come up is to meet offline. You can't resolve them in an hour meeting once a month. And then we talked about the domain and trade association meetings, and I will reiterate, you're welcome to join. That's one way, that was my way to get actively involved in CDM. And on the note of welcome to join, there's loads of resources. Our resources are fundamentally GitHub driven. So whether it's agendas or meeting materials or issues or discussions, they're all happening under GitHub. They're also happening by you can pull code bases, snapshot code bases from GitHub, and that can be an enjoyable way to get started. We've listed the most current in production version of the CDM, which is 5.8.0, and the mislabeled release process, which is really release candidate process. It's called dev, but it's really release candidate, which is 6.0.0.dev.28, which is really to say there have been a lot of activity in building the next release, which is sometime later this year when we get there. You can also go to see the hundreds of open issues, and because it's GitHub, it's everything from a hangnail to it's a major crisis, but good to sort your way through. Generally speaking, if you're scanning the issues and there's a lot of discussion, it's a more urgent issue. If there's no discussion, maybe less. For example, there are some issues on how we're going to take the governance down and implement it at its next level. You'll see any number of postings about that. Pull requests. So you want to make a submission, you have a great idea, you've completed it, it meets the technical considerations, code, your unit tests run, you follow the coding policy, you can raise a pull request. Anybody who's completed a CLA, easy CLA, it's really fast, won't take you long, you can do it for your organization or you can do it individually, can raise a pull request. And those pull requests then will go to one of the relevant working groups. Effectively, we'll go to one of those. It will go to the maintainers, but it will go to the working groups is the best way to vet your pull request and get support. And if you wanted to see, for example, issues that are under review, there's an example, the CWG operating model, SWG, I believe, is really what it was. And there's plenty of documentation. I think you can see the CDM model becoming open source, for example, as an example. So any questions about how we're governed, or working groups, or resources? Again, resources you don't have to jot down. We'll circulate them extra and separately, and quite frankly, go to the GitHub repo and you'll see more than you can drink from a fire hose.
And the one link that's always good to know is calendar.finos.org. And so that just gives you an overview of, on a day-by-day basis, on a calendar day by calendar day basis, where all these different calls are. So you can download an ICS, whatever the calendar format is, and it'll have links to the GitHub repo, and it'll have links to the Zoom meeting as well.
Just to echo something that Dan mentioned, you can just sign up and then you can get access and you can start to participate. That's the best way if you want to learn about it. A lot of what we're going to be presenting here is all extracted from the various pages and so on that are on the site. This is really just to condense things for you so you know where to go. Just going back, if you've heard some company names and some things going on, as it was mentioned, this was originally started by ISDA, and then the first platform or product that was actually built was built by Regnosis. They provided the domain language, which is called Rosetta. Rosetta is also open source, so the Rosetta project is also open source. They also developed the platform, which is for the code generators. So they generate code in Java, Python, DAML. I think there's a whole list of others as well. And they are not under FINOS, but you can see the link is here to their open source project as well. If you have an interest in developing a code generator for a language, any language that's not listed, and you want to work on one, you can do that and then you can submit it. The links there below are just to take you to more details of the technology and the infrastructure and how it all works, how the infrastructure works, from taking the DSL and then building the actual libraries themselves. And for getting started, I have the developer setup link there. That is really the best place to go. That's pretty much almost where I'm going to start once we get into this a little bit. And as you can see, we have a separate page which is more about the entire CDM and the design principles and so on. That's the FINOS org docs homepage. So you can go there. There is code examples that are in the CDM. So if you do download the host CDM from GitHub, there's a section underneath, there's a folder underneath the CDM which has examples in it. I can't guarantee that's going to stay there because we're trying to move examples out of the CDM and keep them somewhere else, but There's a few interest rate swap and foreign exchange examples there. Today, I'm going to demonstrate, again, how to build a very small application with the CDM, and I was able to put it into my own repository. So this is my repo. It's public, so you should be able to download it, and you should be able to build it and run it as we go through. There's a few other applications, or quite a few other applications, some of which are open source out there. I did want to make mention of one which is called an object builder. You'll find out early once you start working with the CDM that the objects themselves, once you see the tree, can get rather complicated. And Regnosis built a open source product called a object builder, which lets you help actually create objects outside of actually having to program them.
And Tom, just as a quick note, so I just added some slides to the Google slide deck if you want to put them on the screen ever, and they have the QR codes for the getting started page, the CDM repo, and your training app.
Okay, I'll bring them up. One way to get started, and pretty much everyone working with the CDM initially starts by working with the model through the Rosetta workspace. The Rosetta workspace has a lot of capabilities into it. If you go to their site here, the Rosetta site, you'll actually see all the tools that are available. I'm not going to really, I'll do some of them as we go through the example here, but I'm just showing you here. I'll put it up on the screen when we get to it. But there's a text view, which is the textual description of the model itself. So that's the text view is actually showing you the DSL, and then you can have a graphical view, which is also very helpful to see the entire tree of how the model is put together. There's a lot of other tools for invalidating your model, testing interfaces to the model, actually calling functions in the model. So there's a lot of tools there that you can actually use when you start to work with it.
Look, just in terms of getting started, there's two ways one might want to use this tool. One is you just want to understand the object structure, and you can navigate to your heart's content through this object structure. And the second is that if you wanted to do modeling, this is a convenient, good place to do the modeling. Meaning, if you think there's a product that we don't cover, there's stuff that needs to be added. So apologies, Tom, for interrupting. I just thought it was helpful to provide some context for why you might want to use this. You want to know what the issue date is of a swap. You can find it from navigating through the graphical view, or for that matter, text view. So that is your interest. And for myself, I built some applications using the Python library, and it took me a while to map the information that was available, the model, not a huge period of time, but some time, in the model to the technology that I was trying to build, which was an evaluation tool. Sorry, Tom.
No, that's right. Yeah, like I said, there's many different directions you can go with this, depending on how you want to use it. And we have a kind of a progression to go through, but we will eventually get to an example of how you can modify the model. And when I say modify it, it's maybe that you aren't looking to change what is there and how it's structured. You may be very happy with the representation of an interest rate swap, but you may say, my own internal platform has a completely different representation. And the easiest thing maybe to do in terms of mapping between your application and the internal model, the CDM model, is to actually model your internal application inside the CDM and use the code generators to generate a library that you can then use to map between your in-house model and the CDM model. Right? So that, I'll show you lots of different ways of actually that you can start to use it. So I'm actually now going to jump right into going through the basics of the DSL, right? So you get an idea when you look at the DSL, when you look at, and I'll just see, let me see if I can just quickly bring it up here. Let me just run through the basics, and then that may be a good time, a good place to stop after that, right? As I was showing you on the screen there, this is the actual representation, the textual representation of the model in the DSL language. When you're going to really have to start looking through this and understand the structure of these objects to understand how to start to use them. And so when you start going through it, you're going to say, what are all these things that are represented there? What are their data types? what are the functions, what are the operators, what's the logic behind it. So that I'm pointing out that once we start looking, or you start looking inside the DSL, inside the model, you're going to have these questions about, okay, what are the basic elements? So I'm just going to go through that now. That's the reason behind this piece of it. What happened? There we go. All right, first thing is just understanding the namespace structure. So this may all sound a little Java because that's my direction on this, but so there's a base CDM base element namespace that has all the date time functions, math, a lot of the basic things like parties and so on that are all the different products. There is the event namespace, so that includes all the business events, the primitives, the life cycles, all the functions and workflow are built into that namespace. The legal documentation namespace, the product namespace, which is where you'll probably spend most of your time looking and understanding how different products are structured, the economics of the product, the payout structures of the product. That's really everything when you start to look at it and you say, okay, how is a swap structured in the CDM? It's all going to be at this level. Observable has to do with things that are really not tradable, right? So we talk about things like prices and valuation. Things are not products, but they are represented or used. So that's all observable, indices and things like that. And then the mapping. I talked about mapping between FIX, FPML, and so on. That's done through a synonyms structure. Every namespace, or most of the namespaces, have these three different types. One is the types. Those are the classes. The other is the functions. And then there are the enumerations. So we have been using since the very beginning hard-coded enumerations. We have a technology project going on to figure out how to move those enumerations outside of the platform. So that's something that's to be considered. So the basic types, here's how they're represented in the CDM. Here's the Java equivalent, and here's the Python equivalent that Dan has gone through so that we can put this together so you can just relate to what exists out there. Integers, decimals, true, false, all look very similar. Text, strings, simple date time, right? Very standard. There are then some basic record types. So these are all built in, right? So this is all pre-built in. So there's a date structure, which is a date structure in Java. There's a simple date time structure, right? These are non-zone, non-time zone structures. And then there's a zone date time structure, which is built in, and that's part of the CDM. The classes and attributes, so the equivalent of the class is called a type in the CDM. So you're going to see this all over. The product, the parties, they're all types. They generate interface classes in Java, same as in Python. There is, sorry, no interface, just class. Okay. There is a metadata type which is built into the model. I'll explain that has to do with mostly doing cross-referencing. So it gives you the ability of having a meta layer where you can cross-reference between different parts of the model. The party, counterparty's ID, the security ID, things like that, so you don't have to keep always repeating them. There's a root elements that are in the model. When you go through the model, you'll see that there's different root elements. They have no parent class other than the Rosetta class. The attributes get defined as all, like in Java, all private final attributes. And then cardinality is defined. So you can define any type of cardinality. It can be 0 to 1, 1 to 1, to make it required, 1 to n, right? It's not actually n. You put 1 to asterisk, and you'll have a list of any number. So here's just an example of what Java generates when you define a class or a type, and then you run the code generator on that type. From the Java perspective, you will get an interface, implementation class, a builder, get and set on all of the attributes, the cardinality validation rules, and string conversions. So all those functions will get generated automatically in Java. So I mentioned the metadata types. So just to talk a little bit about the metadata types, because they're quite useful. You'll see in the model, there is this representation of the open and closed bracket. In the middle is a metadata key. These are cross-reference identifiers. You can tag different attributes or different types, so security types. So you can say a party, and you can put in a cross-reference. And so then you can use that cross-reference key throughout the model. There's a metadata scheme, so you can say the scheme for my identifier is, right, and so you can use the scheme in that, or you can define your own scheme. You could say it's based on some other ISO standard or something of that sort. So that lets you define the scheme. And then you can, instead of copies that are generated, you can use references. So that just gives you the copy and the reference capability. Operators, so conditional statements, but has all of these similar to any other language, if then else. You're going to find some little nuances when you try to use them. It'll complain sometimes about the structure of it. There's no delimiters. One of the things you'll notice, there's no delimiters used within the model itself. So there's no colons or any semicolons or anything of that. There's colons, but there's no semicolons. There's no periods. There's nothing of that. So there's no delimiter, which sometimes when you look at the structure of it may be a little confusing for how do you want to order things. There's also no looping. So if you're thinking programmatically about some of your functions and you think, okay, I want it to iterate over something, there's no loop function built into it. A few things. It does have...
I'm sorry. Lists there are operators on the list. So
yeah.
It's not explicitly a loop, but you can, for example, iterate over a list and execute a common function for each element.
Yeah, so there's no programmatic way of defining a loop from the user's perspective, but these are pre-built into it, as you said, searching through a list, finding data elements, because that's obviously key to some of the things you need to do. There is a filtering capability, so you can filter on attributes. You cannot explicitly filter on content, but you can filter on anything that is predefined in the model. So you can filter on an enumeration. You can filter on a data type. So as an example, I'll show you it comes in, let's say, in a price structure, you're looking for a specific price, which is the interest rate, right? And so that interest rate, the price structure, there may be 3 or 4 different prices in there, and you're looking for a very specific one. You can then include a filter to extract out that object, which is identified as a price, or an interest rate price. So that's a lot of what you do with the filtering, is to find very specific parts of the structure, right? You can just imagine if you're like searching through a JSON file, and you say, okay, I want to pick out a particular tag. That's how it works. Then there's the extract keyword, which actually lets you then pull it in. So you find something through a filter, and then you pull it in, and then you can actually modify the elements. And then there's a reduction capability to return a single value. So a lot of times on the list, you want to actually pull just one value. You want to make sure that you're pulling one value. There's more operators. So these are all pre-built in. So you want to identify sometimes that the list contains only one element. You can identify only element. You want to know how many. There's a count. You want first and last elements from the list. You can do that. You can merge together using flatten. You can sort them. There's distinct, returning just a particular subset of elements. Only element puts a particular constraint on the evaluation path up to a very specific point in the search. And a distinct operator, so removing duplicate elements and things of that sort, which are very common terms. So the function type, so we've talked about types and attributes, operators, and so on. The other is function types, right? In the events, we're all built using functions. In CDM, it's a func. It generates in Java a class in itself. So each function actually generates a class, plus public functions with a built-in evaluator, right? So it has a pre-built evaluator in it, plus a builder. So you'll see in the Java code, there's actually pre-built builders in there. And also, when you're building functions, there's a few different keywords that you can use. So you can alias, which is essentially giving you another copy of the element that you're using. There are preconditions and postconditions that you can put in. There is a set function, which is essentially what you use for just in it like any set kind of functions, like an equals capability. And then there is the add function. So the add has to explicitly be used when you have multiplicity and you're adding an additional item. Just looking at a function here, this is a function that I built for rolling repos. It actually generates an instruction set. So when we talk about events in the system, the engine itself runs by it passing in a set of instructions. So you don't have to actually code the process of how it gets done. You simply code the instructions of what you want the engine to do. And that is built by developing an instruction. An instruction is actually built from one or more primitive instructions. So you saw that list of primitive instructions. That list of primitive instructions hasn't changed in the last 3 years as far as I know. So what we do is when we want to build higher level functions, instructions, we build instructions, we only use those base primitive instructions. So nobody is really going in and changing what the engine does underneath. Just the structure of this is the function name, the annotation. You can have multiple inputs with different cardinality. You get one output, right? So there's only one output, but you can build a structured output if you want to have multiple values in it. The order of this, as I said, is a little predefined, so you have to have your preconditions defined next. There is a very useful function called split, which allows you to take a copy of an object that you had when you started, so the first copy, and then you can split it into two. Very useful when you have trades that have to get canceled then corrected, right? So if you're going to cancel a trade, you normally cancel out that trade, zero out that trade, and then you want to take a copy of it. You don't want to start off from new, so you actually get a copy of it. That's what a split does for you. Then in this particular case, you can see that the multiplicity of an instruction, so it doesn't show here, even though it says that there's one primitive instruction, an instruction actually can hold multiple primitives underneath it. And so what I'm doing here is actually building an array of instructions. And I was talking about the split function. You can see here this quantity change instruction actually is what closes out the trade. And then the next trade actually makes a copy of the trade. So going back to this being a repo roll instruction, we close one trade, we take a copy of it, we move it forward, whatever date has been specified. So you can see that there's a new effective date, there's a new termination date. Those get placed onto the new trade. After the instruction is created, then it will run through a business event. And so it will actually generate a new trade. Just examples we were talking about some of the operators here. I'll just give you a few examples that are commonly used here. So one is that you can test for existence. So many cases that you want to know, okay, the exercise option exists, the instruction, and then the exercise option exists before you do something. I talked about the filter and extract. So this is one that I wrote that actually pulls out, I was giving you an example of a price. So this actually pulls out first the price element, it then flattens the structure, and then I filter for the asset price. So in a repo, there's collateral. I'm looking for not the price of the repo, I'm looking for the price of the collateral. That's tagged to the asset price. So I filter on the asset price and then I extract out the asset. Then I showed you the splitting of the trade. These examples I said, there's actually some predefined functions like create termination instruction, which let you easily terminate the trade without having to go through all the details of that. So that's the basics of the DSL. I know it was probably pretty quick. You'll most likely try to relate some of that to what you see when you're looking at code. And one of the best ways of kind of understanding that a little bit is you'll see that it doesn't come automatically with the distribution, but you can run the Java docs generator, and you'll get the entire list of Java docs, right? So you'll be able to go in and actually see all the data elements that are generated. I don't think we used to have the Java docs distributed, but I don't see them in the package anymore. If you have, you can just run the Java doc generator if you want to get them generated for you.
The Python implementation has the annotations in the library itself. So it's not there's no actual documentation created off of it, but pretty easy to navigate.
The next three sections, I'm going to just go through now, start get into the model, explain the financial products, I'll explain the events, and then the workflow before we get into actually the application. Does anyone want to take a break now? Get some drinks off, get coffee, get a drink?
And what we have here up on the screen here is if you want to see the FINOS getting started QR code. So this gets you to the page that has the contributor license agreement, good first issues, and gives you an overview of FINOS. So if you go to the last two slides, I just added these. So this one that's the one on the left is the same one we showed before. The one on the right is the GitHub. And then on the following slide, once we get there, is the link to Tom's training app, which we'll be looking at here. If you want to follow along on your own, this is to the training app.
Yeah, let me know if you have any problem with the training. I just posted it today. I think it's all set up right.
And Tom, could you turn on your mic again when you get a second?
It's on. On?
There we go.
Okay. It was pointed out to me that we did jump right into the details of the DSL. And that may be some too much detail for where you want to go to get started. You don't have to dig into the details of all the operators and the data types and so on if you don't want to. You can, of course, we keep talking about the link to the CDM, which is here, and the releases, which are here. It currently shows the current production release, but you can click here and you can actually go back. You'll see all the tags for the prior releases. And of course, you can download this, right? You can clone it and download it. But you don't have to do that either. So if you do sign up if you're not signed up on Regnosis, they have a community version, if you would, or a community account. So you just go and register, and you'll get access to the Rosetta platform. And that's what this is here. And actually, you can go into the workspaces and the workspace manager, and this, you'll see, says dev 60028. They always keep the latest dev and production release here. Even without downloading it, you can come over here, and you actually have the model in a text view, or as I said, you can go into their graphical tool as well. Right? Probably the easiest way, if you want to just find your way around the model, look at different things, the best way is to get the Regnosis account and then actually start you working with Rosetta, and then go on to downloading from GitHub. Because if you download from GitHub, you're going to obviously get the entire model, but you won't have any way of easily navigating around it. Any questions on that? Are there any questions about that part of it at all, or make sense? Yep, okay. Getting back to the model, maybe even better for me to work through a little bit of with Rosetta to see this, but I did put the slides in here. You never know what's going to happen. So actually, since everything seems to be working right, let me actually do that. Go back to where it was. That way you'll get a good idea of how to work with this. So we'll look at I'll start at the very top, really, is the trade structure itself. Take a look here, what a trade. So a trade is composed of, I'll just highlight the ones that are most really important here. Of course, the parties that are involved in the trade, right? Different party types, the party roles that each of them may have, the party or the product that's being traded, which is identified as a tradable product, right? This lets you do things like put on the counterparties to the trade and then actually define trade lots. So you may have one block trade or something of that sort. You can have trade lots. Underneath that is the product structure. So this is really where everything is defined in terms of the different types of financial products you'll trade. A contractual product really is the most flexible because it lets you build really any type of product that you want. You can, if it's not predefined, but mostly derivatives and swaps or derivatives and repo and security lending are all built here. The key thing here is then underneath the product is the economic terms, right? So defining what the economics are of the model. And underneath that is the payout. So there we go. So we're now really down to the lowest level of defining what types of payouts are involved in the financial product. Is it a fixed interest rate payout? Is it a floating interest rate payout? Are there forwards? Are there optional payouts? Commodities, cash flows, and so on. So now you're really at the, not entirely at the lowest level, but you're at the level where the economics of a product are defined, right? And if you're going to build products, if you're going to build your own swaps and so on like this, you'll see in the code, once you get to the code, how you need to populate the structure of these products. One of the things on the screen here that you can easily see is that every time you select one of the data types here, it will give you a list of all the attributes and give you the details of their cardinality and so on. I'll just make note of, actually, just this kind of question comes up a number of times as you're taking a look at this or thinking about the model. This is, you can think about this model as a parametric structured model, right? Meaning that as opposed to what many times people ask me, where are the cash flows? There's no cash flow representation in the model. There's the parameters that are used to define cash flows, meaning their dates, the rates that would be applied or how the rate is calculated to be applied, and any other parts of the structure in terms of those cash flows. So you're not going to see a swap with two legs. You're not going to see a swap with lots of legs of cash flows or any other type of product. What the model defines is the parameters that are needed in order to generate those. So it's at a level where you need to figure out, and those will be generated for you. You can use the underlying instruction set to say generate cash flows and so on, but you won't see them in the model. The model's not structured that way. The model is structured like if you were to look at your swap and it says it has quarterly payments and it's based on this index and so on. Those are the parameters that you'll actually see in the model. The reason I mentioned it just comes up sometimes just to orient yourself on what the structure of this model is. So we quickly went down the tree here all the way from defining the trade and defining the product. Typically, you'll start out by defining the product and then work your way back up to actually constructing the trade. Any questions? Anything? Any questions on that? Yeah.
When underlying instructions generate the cash flow, where are the instructions?
They are generated by the application constructing an instruction set, constructing the instructions, the primitive instructions, and then passing in or executing them. Nothing happens automatically without it being triggered, and without it being triggered by calling the engine to execute an event. So there's no process, there's no platform here. It's a model that once you implement it, in order to get it to run something, you have to pass in an instruction and you have to call the event which will generate that instruction or execute that instruction.
But maybe the question is the cash flow generation Rosetta defined, or is the cash flow generation something else? And the answer is going to be, it depends on the complexity of the product, because if it's every reset, if it's every day's equity price for a year, it might be something which is going to use a native implementation. Whereas if it's, I can take 1/2 the coupon rate, then we can all have seen it's pretty straightforward to model it in Rosetta itself. Does that make sense? Yeah.
And could you just repeat the question for the recording?
Oh, sorry. The way I understood the question was, if you wanted to generate a cash flow schedule, where does that happen? And the answer is, it depends. It can be Rosetta native, or it can be Rosetta native, or Rosetta, or it can be native. Just to give a flavor, one of the questions in front of the technology architecture working group is, how do we establish the right controls and boundaries for where something's Rosetta defined and where something's natively defined? And here, if it's Rosetta defined, surely we would want some kind of unit test attached to it. And if it's natively defined, we want to establish the parameters that the natively defined function does work, so that somebody can implement it in Java or somebody can implement it in Python, and a user of the library will know that they've got the same results. Okay.
So if, for example, we are in a generating cash flow case, if we want to implement in Rosetta, then how does it work exactly? Is that the code generator will then translate the implementation into Python and Java?
So the answer is yeah. That's the whole beauty of the machinery, is if you are using the DSL to define a function, then you will get code back. Today you'll get it in Java. In the near future, you'll get it in Python. Code back as part of the library that you can then execute to get the results. But Rosetta, coming back to Tom's comment earlier, Rosetta doesn't have for loops or loops, right? Sorry, dating myself. As a result, if there's material complexity in the calculation of the cash flow, you're limited, right? Right. You're not going to, for example, if your cash flows are contingent and you need a distribution, you're probably not implementing that natively, and actually you're not implementing that natively in Rosetta.
I see. Yeah, thanks.
Yeah.
So that was just a quick overview of the product and the trade structure, right? And that's really the primary model that's in the CDM. And like I said, we can go into a lot more detail of what these products look like, because I'm sure you have questions. If you look at the structure of a swap, you have lots of things that are going on there to define what the schedules, the payment schedules are, what the reset dates are, how dates are actually calculated. So we can go into a lot of detail of just even looking at how all the underlying objects that are there in order to make sure that the dates you're using, let's say, are the appropriate dates, right? As an example, I'll just go through a little bit, show you a little more depth on this so you get an idea of this. So if we go to economic terms, you'll see effective date. Effective date is just the generic term of when anything starts, any type of product starts. And then you'll see there's adjustable dates and then relative dates. So in the repo space, we use a lot of relative dates. It's overnight, it's Tom next, it's tomorrow to the next day, and so on. Swaps are 5-year, 10-year, 30-year swaps. So you use kind of relative dates sometimes when you're building products, right? And so when you're building a relative date product, you have these capabilities of defining various parameters around the calendars and the date types methods that are being used. You can see the period, that's not the right one, the period types, so days, weeks, months, years, and so on. You can peg your calculators to business centers. So it's, okay, we're going to use a particular date, 30-year swap with semi-annual payments, all based on a New York business center calculator and calendar. So there's a lot of depth here to defining. I showed you at a very high level, but I want you to understand that you could take this really to the nth degree in terms of pegging even a date to a particular location and other parameters that are needed to define what that date may be, including, like, say, cutoff times in that particular location, or a cutoff time based on the venue that it's being traded. All of these parameters, you know how complex this can start to get very quickly. Just want to show you the depth of what is there for you to be able to define that. Sorry, go ahead. No, that is not restricted. In fact, sometimes we use that. That process of design principles is something that we look at when things are contributed into the model, but it's not restricted. And part of what happens is sometimes we define a product, you say the product is a basket, but what does the basket consist of? It consists of other products. So we loop back and say, oh, this basket has constituents and their products, and it loops back into a product. Yeah, could a basket include other baskets? Theoretically, it could. But we try to, through only the design process, the design principles, to make sure that we don't have loops in the system that just don't make any sense. In theory, you can. Yes, in theory, you can. There's more switches and capabilities here that you can really design anything you want. So there isn't a lot of restrictions put into it. Yeah.
Does the DSL have a structure to do tracking of that network? Tracking or?
Nothing on the reference side. So if you're referring to, okay, I put in a product and it loops back and define, nothing is in the DSL to validate there. Check that. You can build, we could go into the details of this, but I could build a type and I can put conditions in that data type. And that condition can be something like it can't refer to or can't include a particular product. But those have to be designed in. There's nothing in the underlying DSL that invalidates that.
Tom,
Yeah.
Extend doesn't have some, XText doesn't, I would have thought Antler has, which is what XText is built on top of, has some constraints on ensuring that you don't model something that's syntactically invalid.
Syntactically, yes, but I think we're talking about structurally, right? You're talking about referring.
In that, sorry, when I say syntactically, that you can't have a circular reference. I would have thought that.
Not that no, because we've done this in many cases. The basket is an example of it, but I don't think so.
A basket can contain itself as a basket?
It could. If you went to a basket containing a product and the product is a basket, it could contain.
No, sorry. A basket can contain itself explicitly. The instance of a basket can contain itself.
That I don't sure. That I'm not sure. That may be, at that level, that may not be.
So that kind of syntax, I think Antler will, Xtext, which is the Eclipse, the version of Antler that we use, that Rosetta is built on, I'm sure Antler has checks for that kind of syntactic or sensible construction of grammar. That said, it's not a compiled language. You're not looking at a compiled language.
And potentially we could dive deeper on that in the whiteboard session.
It'll be learning for all of us, I bet.
We could actually test it out and see how it does. While we're here, I thought, well, let's take a look at a interest rate payout. So we use interest rate payouts for swaps, but we also use them for repos as well, just a more simplified version of it. But in an interest rate payout, which is really designed to be used specifically with a swap, you can model then your floating rate payouts. Oops, where's the floating rate? Oh, that's a floating rate amount. Sorry, where is it here? Let's see, fixed amount, floating amount. Receiver principal amounts. Rate specification, so I can have a fixed payout and a rate schedule, and then I can have my floating rate and my floating rate schedule. And this includes all types of things that you'll find in complex ISDA agreements that define things like in a fallback condition, rate's not available, the rate's not calculated, what's the fallback rules. There is spread schedule here, initial rate definitions. So there's all kinds of treatment that everything that makes up a more complex swap, and certainly anything that would cover that's needed in, let's say, an ISDA agreement. We use it also for repo, very simple case, just a starting and ending and a rate. Just while we're looking at repo as well, we can take a look at, where are we here? Go back here. I think it was under economic terms. Sorry. Collateral, right? So collateral is the other side of the repo. You can have portfolios of collateral. So you can define in here what goes into the portfolio, and then you can separately define collateral provisions. So if I have a more complex, sometimes you start out with a repo and you actually don't know what the collateral is. But you say, okay, we're going to trade whatever, 100 million and I'll give you this rate on any treasury less than 5 years, right? And then it's up to the seller to come up with all the treasuries less than 5 years. So you can define eligible collateral. A lot of work is being done in this area by ISDA as it relates to the collateral agreements and various other ISDA initiatives that are going on. So this is a lot of work actually going on. We did this for repo baskets as well, repo general collateral trades and tri-party trades where you really just define a set of parameters. So you can define the asset characteristics of what you're willing to accept. You can even define the issuer. So it's just US government bonds, these kinds of things, right? So it has a lot of depth in here in terms of actually really going down and defining what it is that makes up the product. So you can start to see already, that's why it's much easier for me to do this than on PowerPoint, is to just show you how far you can go into the depth of building this model. Any questions? Yeah.
I think you mentioned there's a rate, the specification, something like that. Has the LIBOR transition, you have a LIBOR rate before, now you fall back to the RFR rate, things like that. Is that modeled in this CDM?
Litek, do you know if it is, or?
ISDA published the 2021 definitions, and as a result, there were changes to FPML to support the new floating rate indices, and the CDM like imports or reuses those floating rate indices via an enumeration. So I think it's supported in CDM.
Just because you mentioned it, I remember seeing something. I don't know to what extent it covers what you want, but there is an object that was created for index transition instruction. So this is an instruction, right? And this was built specifically so you can define certain parameters of how the rate is supposed to get converted, what the transitional process would be, and how the rate would be converted. I don't know, I can find somebody who did this work. And if you want to know more about it, just shoot me or shoot Litek a message or something like that, and we'll get you more detail. I don't know who did it. That's the thing about an open source. Lots of people do things, and you don't always know where it came from, right? But I do, just because you mentioned it, I remember seeing this.
We could look at the Git blame during the. We could look at the Git blame during.
Yeah, exactly. Yeah, I don't know. So that is a lot on the product, and we can come back to that. And I'm just trying to mindful of kind of trying to move through the product here. So let me actually jump out of the product and into the event structure. So I mentioned that the underlying engine runs on instructions. You pass in an instruction, and then it processes that instruction. That event is called a business event. The business event can be composed of many instructions. So you can close a contract, you can make a payment, you can do a transfer, you can do lots of pieces of an instruction itself. What makes up the process of executing an event is that you are defining the after state in the instruction. So you're defining what the state of the object should be after the business event is executed, right? And through that would be something like the actual trade. That's what we looked at before. And this is the state. So you can say, okay, this is open or closed state. So that is the key, one of the key elements of what you need when you define the business event. You can just take a look here. Sorry. So you define the after state. There are other optional parameters, but you define when, the effective date of when the event takes place, and then you define the event date, and then you define the instruction. So this is the instruction. This is the primitive instruction that will get executed to go from the before state to the after state. The instruction itself contains the before state, right? So we have a trade. If you're starting out from nothing, it's null. You don't have any trade. You define the after state. The after state is the execution. But let's say now you're going to do a reset and there's a new cash flow generated. So the old state would define what it looked like before. New rate is applied, new cash flow generated. that would be executed, and then you'd have a new state for the object. These are all the events then can be linked together. So you get this lineage of events that actually take place. So that's a key part of it. And I think we were showing a slide earlier of all the primitive instructions. In order to do any of these business events, you have a menu, right? You just basically have to look at what type of event you're trying to execute, and then combine or select or combine the events that are available from primitive instructions. So it has to include a primitive instruction. You have to wrap it into an instruction, and then you have to do the business event. That's the way that's the way products move through the entire process. Any questions on that? Just on one level up from that, I'll just go back one level. The level above a business event is a workflow, right? So now you think about the entire workflow of what happens from the time you execute a trade, and then let's take this in the OTC world, you have to send a confirmation. That's another step in the process. You get a confirmation and acceptance on it. It forms a contract. It's another step in the process. Now you have a contract in place, and then, of course, there's a number of life cycle events that go on. The swap is then matured and then falls off. All of those are business events that take place. The overriding on top of that is the workflow events. And the workflow events are just made up of a number of different steps. Let's go on here. So you can see that every step encompasses some type of a business event here. Right? So we have the business event that takes place, but you build up this series of workflows yourself. So this is not something predefined in the model. You build your own workflows, and then you use and execute the business events.
Can you import or work with other kind of workflow toolings or workflow representations?
We are currently looking at that. There's a few different things. You can, of course, build your own workflow model. This would be like outside, where you build some kind of a workflow capability to show what the steps that are allowable steps are. But it's not an official project yet, but looking at using the BP mapping models, right? So you could actually take XML, define XML workflow structures, and then use those as your templates of how events would take place, right? Is that what you were referring to?
Yep. Thank you. Very cool.
So this actually just wanted this as a kind of stopping point, this kind of just quick high-level view of what the product structure is, what a trade is. These are all the basic elements: product structure, trade structure, events, business events, and workflow. Those are the four major components, almost maps directly to the namespace structure that you saw before. Okay. Question?
No. So quick look of Antler. Grammatical consistency comes from Antler itself. Grammatical consistency comes from Antler.
Correct. Yeah.
So
Yeah.
inconsistent language.
Sorry, I have a question. My understanding is that all this model is, let's say, use Java or C++, is like the libraries. Then where's the main? The main function.
Yeah, the main function sits outside.
So essentially, we need to use this model, then use the code generator, generate the library, then we link with the library, and then we write our own main.
That's correct. Yeah, that's exactly what the training app shows you. The training app was just a very basic app, Java main, and then it immediately starts making calls to the library.
But let's not lose the value proposition here. You go in and use the library. You have a data model, which is industry standard. You have functions which are operating on the data model, which are industry standard. Huge simplification. If and when CDM takes off across the industry, it's a huge simplification, because no longer do I have to worry about, oh, I think my interest rate swap looks like it's all green, and you think your interest rate swap is all blue. And somewhere we have to do a translation between green and blue. And is it CMYK or is it RGB? I don't know. Now it's simpler. We're both using the library. We both know what an interest rate swap is. We both know what a reset is. And we not only do we both know, but we both know exactly that we both know exactly the same thing. So the data itself could be different. Is there a centralized repository? Is this proposing a centralized repository? That's not what this is proposing. But the data model and the functionality is common. And that's what was intended, I think, all the way back to ISDA's initial foray, right? To really make something that is a quantum step forward from FPML, at least in my view.
And did that answer your question?
Is there a standard disk representation for this as well? So if I wanted to send someone, let's say, all the data of the trade, or if I wanted to store it, because all this works great in memory, but what happens when I turn off my computer?
Yeah, I was going to get to this a little bit later, but you've hit on a fundamental part of what you need here, right? There is a Rosetta serialization process that's built into the model. Dan's like, there's limitations on what it is in the same way that standard Java serialization has certain limitations on it. But what I'll show you, I was just about to get to this part, right? So you can after you create a product if you want, like you haven't done anything with the product, you can serialize it, you can store it, right? So I have templates of swaps or repos. They are products that I've serialized the structure of it, and I put it into a Mongo database. That was the easiest thing to do, right? So you now have that I can go back and I can pull it out to be used again. You can more actively take your trades, which are the result of your business events, and serialize those into a JSON structure, and then you can store them somewhere, right? Because if you're going to be doing these events in this process, like you see that you have a before state, after state that you have to do, somebody comes along and says, okay, I'm going to reset. I'm going to do a reset rate. I got to put a rate in. You get the old object. You come back. Of course, you represent it, let's say, in a GUI or something like that. And then to get it back into the application, you're going to read in the JSON structure, deserialize it. It will deserialize into the CDM object. And you have all the services that are there that were previously defined to work on that object. So that's what you do. You read it in, you deserialize it, and now you have an object, a full CDM object that you can execute on. I do that that's entirely throughout the entire application process. Everything you want to do, going from one event, one step, is all deserializing the object structure that is there, and then, serializing it, then deserializing that structure to read it in, and I'll show you what exactly that looks like.
Yeah, a moment ago, I made a strong argument for the benefit of CDM. I'm not a trade association member, I'm a technologist. I think CDM should be adopted, and I think the industry should be working toward it. But serialization is not a sorted topic. Tom described that there is, and it was an ad hoc solution earlier on, a mechanism using JAX-P to serialize CDM objects so you can store them. There are huge defects with that solution. Not that the JSON's not properly represented, but things that you would expect aren't there. For example, the version number that was used, so Tom described to you how the modeling is done, and we have different versions of the data model. That is not contained in the JSON that's serialized. So therefore, if I hand you JSON and I'm on version 5 and you're on version 4, maybe you'll understand it and maybe you won't. And so and to be fair, serialization is the #1 technical concern that's been raised to the steering committee, and it's waiting for funding to be implemented.
So, look, CDM is in production, and there are, of course, issues with, as Dan has pointed out, the versioning, the tagging of the JSON structure. So what are you actually reading in, things of this sort, right? So there's a lot of issues, security, these sorts. There's nothing to stop any using what is there. It's not broken. It works within the same context of the version of the model that you're working with. And as far as I know, it's not going to corrupt anything if you happen to read read it incorrectly. I haven't seen anything of that sort. Yeah, it is an area that actually we've spent a lot of time looking at different options, looking at different standards, figuring out which way to go. Haven't fully decided what that direction, what that roadmap is going to be yet.
Be fair, Tom. The steering committee recommended a direction and it was ratified.
Dan, can you go on mic?
Sorry about that. I'm just asking, let's be accurate. The steering committee identified a direction, or a steering working group identified a direction. It was ratified by the steering working group. It was put out to proposal, and a solution was accepted. What it's waiting for is execution, and the execution is contingent on funding. But it's not, look, that's the pain and benefit of open source, right? It's something that people can contribute to.
And the opportunity from an event like this in driving towards FINOS community contributions.
Since you brought it up, this was the slide that I had because we'll show exactly what you need to do. Serializing, you basically are passing in whatever the JSON structure is. That's the easy one. The deserializing is a little bit more of a product limitation because you have to know exactly what class you're reading it into. But this is basically how it works.
And on the Python side, it's almost the same. Since the Python implementation is using Pydantic, you can serialize and then, since it's a new version of Pydantic, validate model reading it in. Very straightforward, but you need to know the object you're creating before you create it.
It also reminds me of one of my favorite technology jokes, which is, who's this guy, Jason Parser? I keep hearing his name. We should hire him.
I'm just going now to get to the app so you can see, I think it'll be as self-evident and answer a bunch of questions that you guys have probably had or thinking about. Just before I do that, and you'll find this on the developer setup page, is what you needed to get started. Now, you could have, as we said, you could just download the entire GitHub. That'll give you the code generators. It'll give you everything. You can work inside the model if you want to add your own project and use what's there. That actually works out pretty well if you're trying to modify the model and actually build an application at the same time. So sometimes that makes it a little more efficient if you want to do that. But you don't need to. If you're not going to modify the model, you just want to take whatever the latest is, this is what you need. You just need to include the Maven dependency. So every time we do a release, whether it's a development release or a production release, we push it to Maven Central. So all you need is this in your POM file. We use the Google Juice injector, and then there are a number of dependencies that you'll see inside when you build an application. Right? We found out today we fixed the problem. You can actually build with Gradle as well. I think we are at the point where I'm actually going to answer some of your questions, and you can actually see what happens here. So you're started out basic main in here. I'm simply making one call, which is to my workflow plan, right? And this is a very simple case, which is it's going to create a trade, and then it's going to cancel the trade. So that's my entire workflow step. This is the workflow plan. I'll actually come back to this because I want to get into probably what is the easier part of this to see, right? So the first step in the process, I'm going to create a new trade workflow. So I create a workflow step. These are predefined functions that are in the CDM, right? So I call the workflow class. I call the workflow step default, which creates the class. I do the injection on that. I have to set up my dates. I said I needed an event date, and I needed a date for the event date and time, and I need an identifier. So this is what's needed to set up my. So now I'm actually going to go through just those things that I need to build a product, right? Or build a trade, I should say. So build a trade. So what do? We looked at what a party structure was. This is the simplest I could build, right? So I simply am defining what the product name is. So all of this code here, the set functions, set and get functions, and the builder, this was all generated simply by creating the party data type and its attributes. And the code generator did the rest. So I create a party 1, I create a party 2. I could go much deeper into the party structure. I can put its LEI, I can put its location, its name, its contact information. You can get much more complicated with these. I wrap the parties into a list. The next step is that I have built my workflow step in this process. It's kind of using some things that I had here before. And, sorry, just looking for my event here. Here's my trade event. Where's my, oh, cancel, sorry. Oh, execute trade, sorry. It's off a little bit on my own there, sorry for a second. So this is, sorry, executing the trade, building the parties. I wrap the parties in lists. I define their roles. One is one's a buyer, one's a seller. I define an identifier, which I remember I mentioned about schemes and reference values. So a field with a meta string, this is a key type or a reference type. And in it, I'm defining just a UTI, so there's a transaction identifier in here. So this will build my entire object for a trade identifier. I need then the execution details. And here I say it's off facility, OTC. I put in a MIC code is my scheme. This is the value. I call it the bond ATS, which is my scheme. And then I can build that. That is my execution details. We talked about the product. In this case, I've kept it very simple, which is I created a security type product. So you'll see over here where it says set security. So I'm not building a complicated swap here. I just said set security. And I set its identifier, which is one of the enumerations for product identifier is an ISIN. And then I set its ISIN in here. Right? Then I define the price structure. So in this case, of course, I don't need lots of complicated things. I'm not defining the bond interest payments itself, right? I could do that if I want, but this is really just a secondary market trade, right? I set its price, I set its currency. Before, I remember I mentioned it's an asset, so I define its asset price and how its price is defined, which is the expression, which is a percentage of notional, right? I then define the quantity structure. Here I'm just trading 1,000 bonds and what the currency is. Next step is to define the counterparties. I've already defined who party 1 and party 2 are, so I have who the counterparties are. And then this is that step that we looked at before, which is creating the instruction, right? So this is a predefined wrapper, if you would, to easily define what an instruction is, right? So execution instruction builder, all the things that I just created, all the objects I just created, the product, the quantity, the counterparties, the roles, all of this gets packed into the instruction, right? I then take the instruction, run the instruction builder, which takes the instruction, packages it inside, takes the primitive instruction, packages it inside the instruction. There's a little bit of setup here that I need to actually execute the business event, right? Which is through the injection. And then I finally get down here, which is the evaluator, right? So I mentioned that there's always everything that gets generated, every function that gets generated generates an evaluator. I pass in the instruction set to the evaluator, and this actually executes the trade, right? And that whole process, I then, as you said, I deserialize this, and then I pass it back into my workflow step, which was somewhere up here. Let me just find it. The easiest way of finding it here. Somewhere up here, yeah, in the workflow plan, that was the first thing I did, was to execute it. So I take the result of that, which is this deserialized, serialized, and then I then go to the next step by serializing it back into an event. So I need the trade object in order to go to the next step. So I'll deserialize it, and then I will come over here, which is after I've now deserialized it back into an object. I can now go into the business event, and extract out that element, that part of the object, which is the actual trade, right? Which is the actual trade state, which is the after state. So now I've extracted one piece of the object that I need. I then go back and I actually deserialize that, and then I will then go into, because I'm going to pass that serialized a string into my function to terminate the trade, right? So I represent this doing this constant mapping of the serialization, deserialization, just because that's the way you hand things off. If you put it in a database and you want to hand it off to someplace else, or you put it in a message or send it through like Kafka or some kind of message structure, you just are always pulling it back into a string. So that's what I was trying to just, I could just do this through the objects itself, but the idea was just always bring it back. And especially when you want to extract out elements of it, you would do this. So then I go back into the terminate trade. Just go down to the step terminate trade, right? And so now in the terminate trade, I've just passed in this JSON structure, which I will then go through the very similar steps of canceling this trade, right? So I deserialize it again, right, into getting the trade state. There is already a predefined function that's built into the CDM called create termination instruction. So I don't have to go through the details of actually doing every piece of it. The function actually exists there, so I just need to pass in the information like the date and the instruction itself, so the date here that I'm actually going to execute. So this will be the event date here. And then I can go through this whole process again, and actually I'll return that serialized back into it. And I might as well, while we're here, run it. Okay, all good. Let me just find it here, wherever it is. Where is it? Sorry. Should have had this set up already. What's that again?
Nothing more frustrating than losing.
Yeah. All right. Okay. So here are the 4 steps of what happened in that process. The first was the execution. So here's the business event structure. It includes, we said, the event date, the effective date, and then the instruction consisting of a primitive instruction, which is then this execution in here. Look at the product details are in here. I mentioned all the price, quantity, the counterparty, the parties, the party roles. All of that is now essentially, out formatted. And then this is the after state. So this represents that was the instruction. This now represents the after state of that object. I output each one of these. We won't go through them unless you want to see them, but each one of these, the execution, the new trade, actually new trade came first, really, new trade, execution, the cancel workflow, and then the termination. This, like I said, if you look, you can get this app. This was the easiest way for me to represent how easy it is really to get started. As much as we've spent the better part of an hour going through more complicated details of that model, I did want to make sure that you really understood how simple it is to get started without having to take the whole model and actually start understanding and working with the model details itself. Like all the DSL and all of that, that's all great. You need to understand that in terms of what the attributes are and how you work with them. But this is the easiest way if you want to get started with it. So we'll take a moment there with some questions.
So I see in your main function, you called some of the functions defined in DSL. Is that right? Can you show us where you define those functions in DSL?
So some of them are libraries that are pulled in automatically. So all the Rosetta code is not, it's the libraries get pulled in through the plugins, but they are not, that Rosetta code is not on the open source library, on the open source.
Which functionality were you using?
You're talking about the Rosetta object.
For example, when you build object, you may call set, name, value, those kind of functions.
So these are, yeah, so these are the set name and everything. So let's take a look at what you were talking about here, like in the execution trade, right? This piece here.
Yeah.
You see that okay? Yeah. So this is what's generated by the code generator, right? So that actually came out of, let's look at party here. So here's the party data type, right? Let's look at the text there. So here is the name, right? Here's the name in the DSL. Code generator automatically generates the Java code to generate the set and get functions.
The Java code.
Yeah, Java code generator.
Python, there's no private data, so Python you just change that.
I see. So what are the functions that can be generated? Like we have set, do you have, I guess, also get name? But maybe, is there any a full list of the functions that can be generated?
What a type of function?
For example, I see you have set name, right? I guess there is also maybe get name. So what are the full list of functions? Just the getter and setter, or is there any?
Yeah, only you have no control over that. There are only getters and setters, and then variants that are needed in lists and things, right? So there's an add, and there's, I don't know, there's a remove or delete or something of that sort. But those are all predefined. Let's just take a look at.
Can I just ask a question while Tom is looking? You could be asking a few different things, and maybe, at least maybe I misunderstood. You could be asking, I'm going to say something it's not formally right, but it's right. What native functionality comes out of Rosetta? So getters and setters for the Java implementation come natively from Rosetta. You could also be asking, what can we see a Rosetta-defined function and see the Rosetta definition of the function, and then we can, of course, look at the Java implementation. If that's what you're looking for, then we need to go. If we could look at...
Yeah, maybe we can take an example like where we define a function in DSL and how it look like in Java.
Yeah, perfect. Okay.
Just as a quick time check here, we have to be out of this room right at 5, but we have the conference room booked for continuing discussion for whiteboarding. Maybe we can show this example and then start to wrap up and move to the other room as needed.
Okay, that would be good. So I think I can answer your question. So the DSL is this, right? So this is our party type, right? And these are the party attributes, including some of the meta tags, right? A function, okay, we can. Let me get to one. Let me do the easy one first. So this is the party, right? The Java code that's generated from it, the Java stub, if you would, okay, the doc, the generated, will have these functions built into it, right? So you'll see get name, get party ID, get first, right? And then the builder itself actually is what you really probably want to see, which has a lot more detail in terms of both get and set functions. So they're all there, right? You want to see the actual Java code, or is this, you get it? This is fine, that's what I thought.
I think it's the Rosetta-defined function and the ensuing Java code.
But no, I think this is the Java stub.
We have Rosetta-defined functions, right?
Yeah, but we don't have those, we don't have the code on the Rosetta, not the Rosetta object. You're talking about the Rosetta object, the engine? No, you're talking about...
There's a Rosetta-defined function. whatever execute trait. And then there's some Java code that's created by the generator
Yeah.
that we could also look at.
So that's actually not a Rosetta function, that's a CDM function. So there's a distinction.
Yes.
That's the distinction is,
Rosetta-defined function for CDM.
Yeah.
It's the equivalent Java code.
yeah, we could take a look at, let me see if I can get create. Oops, what is that? I'm just going to see if I can find one here. Huh. Strange. No way I don't have that. Let me try.
For the Java library.
Okay. So this is the stub of a exercise event, which I believe is a function. No, this is not the one. I'm getting an error on the location of these. Oh, okay. Let me see if I can find one for you. Anyways, I can find the function. We can take a look at the Java code if you want to do that. You can move over. I mean, we didn't get into actually modifying the model. So remember I said there's a couple of different tracks we can take here, which is, I did the very basic, which is how do you pull in the model? You want to actually now talk a little bit about, like we talked about application integration. If you want to model your own application structure, let's say, I know some of you guys you have a bunch of calc route things. Yeah. And you want to say, oh, we want to model that calc route into a real model. I say real model, into a model structure in the CDM. You can do that, right? And that's one example you want to pick on. But that's what I'm saying is that you may have a fixed message, right? And you say, okay, this is a structure of my fixed message, right? You want to model, because that's not represented directly in the CDM. We have a party and we have everything else. We don't have fixed messages in there, but you may want to, and you could actually model out the structure of a fixed message.
Actually, we have FPML.
You have FPML.
Then on the Rosetta, there's a UI.
Yes.
You just drag and drop that FPML plugin to the UI.
Yeah. Yeah, FPML, a lot of this was derived originally when they were working with FPML, but that process that you're talking about, that's not in the model. That's in Rosetta, right? So Rosetta has an engine to do exactly what I'm talking about, to read an FPML structure. It actually can do an FXML as well. Regnosis proprietary, to read it in and remap it into a CDM object. But that's in the Regnosis.
With respect to the question that was asked.
And yeah, Mike.
Sorry, just real quickly. Add, I found the Java code. Add, we can look at it next door. Add days implied is the function. It's in CDM-based datetime functions. And in the common domain model, you can find the Java code. So we can do that next door.
Cool, and we are at 5, so I just want to make sure that we're respecting everyone's time. So if you're not able to join us next door, I want to say officially thank you for everyone to coming. Thank you so much, but we do have the room next door booked for the next hour, and we can continue the discussion with any Q&A, whiteboarding, and technical questions. So thank you very much.